In this video here, we're going to take a look at modulus inequalities. Now, we also need to be able to solve inequalities that include modulus signs. And for inequalities like this, it's good practice to sketch the modulus graph. So I'm kind of hoping it goes without saying here, but being confident with modulus functions and sketching modulus graphs is basically a prerequisite for this video here. So a bit of a warning for continuing with this video here, just make sure that you're confident with those skills. So there we have it, right? We don't need too much more here in terms of an introduction to modulus inequalities. The best way to demonstrate this is to run through a couple of practice questions. So as it says here then, let's just work through some examples together. So let's get started here then with question 1. So as we can see here then for question 1, right, we want to solve the following modulus inequality. So the first thing that we should do here is just start with a sketch. So if I do that over here towards the top right corner, this here then is my y-axis. And we also have our x-axis here. Okay. Don't worry too much if your axes look as unneat as mine. It doesn't have to be perfect, just so we can kind of visualize the problem. So the question here then is, what do we actually want to sketch? Well, what we want to sketch here is y equals the modulus of x squared minus 6x. We also want to sketch y equals 5. Okay. So if I do this here in different colors then just to make it clear. So to sketch the modulus function here, then let's just consider y equals x squared minus 6x. Okay. So clearly on the right hand side here, we can factor out an x. So I get x times x minus 6 like so. And if we now set y equal to 0 here, then clearly x must equal 0 and x must equal 6. Okay. I've got 0 there. And let's say then that 6 is here. Okay. So because we're taking the modulus here of the full expression, then anything below the x-axis here actually gets reflected in the x-axis itself. So in other words, anything below just goes above. Okay. So to sketch this here, then we'd start in the top left corner. We'd come down like so. So normally here, we just go underneath, right? We kind of go from the top left corner, go through, we dip down and then come back up. So if I show that here in a different color, let's do it in green, for example. We go underneath here like so and cut through at 6. And then we just come back up here like so. Okay. Just a basic parabola here, quadratic, right? This should be very basic to sketch. But the issue then is, like I've just said here, we're taking the modulus of the full expression, so anything below goes above. So altogether then, this would go above like so. And as you can see then, we get this funny looking W shape here. So if I join this up then, like so, you get the following here. So hopefully your sketch is much neater and nicer looking than mine, but you get the idea here. So what I've just sketched then is y equals the modulus of x squared minus 6x. Okay. Let me just quickly remove them. The green dotted lines here underneath, just so I don't cause any confusion. Okay. Now, what we also need to sketch here then is y equals 5. So that's much easier to sketch, right? If we say that that's 5, then this is just a horizontal line straight across like that, right? It should clearly just be a straight line, but I'm doing it freehand, so it's not perfect, but you get the idea. And hopefully what you can see here then is I get 4 points of intersection. Okay, we get this point here, this point here, this point here, and then finally this point here. Okay, so it would look certainly a lot better if my diagram was bigger and drawn a little bit neater. But as you can see, then we have these 4 points of intersection. Okay. Now we do need to know what these 4 points of intersection are. So what I need then is the critical values here. So for the critical values then, which we'll shorten to C dot V. So for the critical values here, we need to solve the following equation. So we have the modulus of x squared minus 6x is strictly less than, sorry, not strictly less than. We're solving an equation here, so it helps if we get this the right way around. We want the critical values right. So we set the modulus function here equal to 5. Okay. So now to solve this modulus equation here, what we need to do then is consider both the positive and negative argument of this modulus function here. So if we start then with the positive argument, so for the positive argument here then, so what would I get then? Well, that would simply be x squared minus 6x equals 5. So if I subtract 5 off both sides then, what I get here is x squared minus 6x minus 5 is equal to 0. Okay. Now the hope here then is that this would just factorize, right? And then we can easily solve. But unfortunately, in this case here, this doesn't factorize. So we can either complete the square or use the quadratic formula. I do think completing the square is a little bit quicker and a little bit easier. So I'll use that method here. So what would I get here then? I get x minus 3 all squared. I then get minus 9 and minus 5 is still there. That's all equal to 0. So minus 9 minus 5 is minus 14. So what I've got here then is x minus 3 all squared is equal to 14 here. So clearly in this case here, we're solving for x, right? So take the square root of both sides here. I get x minus 3 is equal to, don't forget plus or minus the square root here, 14. And then finally then, right, if we just want x here, just add 3 to both sides. So x is equal to 3 plus or minus the square root of 14. Okay. So this here then gives me 2 points of intersection here, but clearly at this point we're not quite sure where they would match up, right? So I also need now the remaining 2 solutions here. And to obtain those, what we need to consider here is the negative argument. Okay. So for the negative argument here then, what I get is minus x squared minus 6x here, and that is equal to 5. Okay. So what I get then is minus x squared plus 6x is equal to 5. So now, because this is negative here, I'm going to add that to both sides. I'm also going to subtract 6x off both sides here. So altogether then, what I get is x squared minus 6x here plus 5 is equal to 0. Again, because I've just got a quadratic here, what I'd hope is that this does factorize. And the good news here is that this does indeed factorize. So what I get then is x minus 1 and x minus 5. Okay, that's equal to 0. And as I can see here, then I get 2 solutions. So we get x equals 1. And we also get x equals 5. Okay. So in that case, then we can now clearly mark on our diagram here these 4 points of intersection. So this furthest point here to the left, that would be 3 minus the square root of 14. So that's 3 minus the square root of 14. This one here then is 1. This one here is 5. And then for this final point here, that would be 3 plus the square root of 14. Okay, so 3 plus the square root of 14 there. And we're pretty much done here now. So by using our graph then, we can now identify the solution here. So let me do it in, I've already used red. What color have I not used? Let's do it in orange. So what I'm looking for here is where the modulus then, so the modulus of x squared minus 6x is less than 5. So where is my modulus function here? So that's this blue graph below this straight line here. Well, clearly then what I can see is that this is between this solution here, so 3 minus the square root of 14 and 1, okay, as we can see here, like so. And it's also the same here then for this point here, okay. So hopefully that's kind of clear from my diagram. So obviously this point here, the modulus function is greater than 5, right? It's above the red line. Again here, anything to the left of this is above, and then same again here to the right. So basically you just want to be below, which is these 2 points here. So the solution then is as follows. So as we just said then, right, between these 2 points here, this point here is 3 minus root 14. So 3 minus root 14. Obviously, this is a strict inequality here. And we're solving for x, right? So x is between 3 minus root 14 and 1 then. Okay, once we go past 1, we are greater than. And we also have then between 5, again for x here, and then this final point here of 3 plus root 14. So 3 plus root 14 there, and there we have it. So the solution is the following. Okay, let me just quickly highlight that here. Like so, and there we have it. So I do quite enjoy these questions personally. You do need to draw a graph, as you can see here, and it is important to kind of mark on as you go in through the question and your diagram, the important bits of information. Okay, so there we have it. That gives us the solution there to question 1. So let's just have a go then at one more question here. So for the very last question, question 2, as we can see here, right, we just want to solve the following modulus inequality. So just as we did for the previous question here, our first step in solving this modulus inequality should be to start with a sketch, okay? And we'll do the same here then. So for the coordinate axes, doesn't have to be perfect, by the way. That's my y-axis, and this here then is my x-axis, like so. So what do we actually want to sketch here? Well, what I want to sketch here is y equals the modulus of 4x plus x. Now, straight away, that's a problem. Okay, trying to sketch that is not the easiest. So the way that I overcome this problem here is to start by subtracting x off both sides. Okay, so if we do so here, we get the modulus of 4x is strictly greater than 3 minus x here. Okay, and now sketching both the left-hand side and the right-hand side here of this inequality is much easier. So let's do this in different colors here. Now, I'm going to start by sketching this linear straight line here, just because trying to kind of draw both of these on at the same time, my art skills are that bad. It's a little bit tricky to actually show the points of intersection. So let me start by sketching this here. So y equals 3 minus x here. Okay. So this will cut through at 3 here. It will also cut through at 3 here on the y-axis, like so. So clearly this should just be a straight line here, like so. So that 3 straight away is going to get in the way. So let me just quickly get rid of that. Let's just continue that down, like so. That would just continue it, right? Like so. So this is just a straight line here, cutting through 3 on both the y-axis and the x-axis here. Okay. This here then is y equals 3 minus x. Okay, cuts through at 3 here as well. 3 there on the y-axis. And now, let's do the second graph here in dark blue. Well, this is just the modulus then of 4x. Pretty standard and straightforward to sketch here. We just get that kind of classic V shape here for modulus functions. Okay. So this would just be a straight line here. So this is just y equals 4x. And normally this would just go down, right? But in this case here, anything below the x-axis will be reflected above, right? Because we have the modulus of 4x. So in that case then, this will just be reflected above, like so. Okay. And as we can see then, we now have 2 points of intersection. We've got this point here, and we also have this point here. Okay. So what I need now is the critical values. Okay. So let's make a note here. So for the critical values then, here, we need to solve this here then. Okay, so we're going to solve, well, I say solve this here, not the inequality, but if I make that an equation. Okay, so the modulus of 4x is equal to 3 minus x here. Okay, so where can I begin here? Well, what I need is the positive and the negative argument, right, of the modulus function. Okay, by considering both the positive and negative argument, we obtain these 2 points here. So for the positive argument, here, that would simply be 4x equal to 3 minus x. So 4x is equal to 3 minus x here. Just solving this straightforward linear equation, we get 5x equals 3. And therefore, in that case, x is equal to 3/5. Okay. So that's clearly this point here, right? Because this one is obviously negative. So that's 3/5 there. And now for the negative argument here. So now for the negative argument here. Well, I now take minus 4x here is equal to 3 minus x. So minus 4x is equal to 3 minus x here. Okay. So let's add 4x to both sides and subtract 3 off both sides. So if we do that here, then I get 3x is equal to minus 3. And then finally, just divide both sides by 3, right? And we find that x is equal to minus 1 here. So this point then is minus 1. Okay. And we're nearly done now. So now let's use our graph here to help us identify the correct regions here that satisfy this inequality. And I think yellow is not a good choice. I can barely see it on the background. Let's try dark green. There we go, that's a bit better. So by looking at this graph here, right, what I want then is where the modulus of 4x is strictly greater than 3 minus x. So in other words, where is the modulus graph above this straight line here? Okay. Well, what I can see then is anything to the left of this point here, which I'm shading in green here, is above, and same again here at this point. Okay, so anything to the right here of 3/5 is greater than the straight line. Okay, so the solution here, is the following. What I found here then is x must be strictly less than minus 1. So x is strictly less than minus 1. Or x is strictly greater than 3/5 here, right? As we can see, where I've shaded in green. So x is strictly greater than 3/5. Okay. And let me just kind of highlight here that this is our solution. Okay. And there we have it. So that gives us the solution there to the very last question, question 2. And that brings the end then of this video here on modulus inequalities.